All right, students, we just got done with looking at polynomial functions, which was a pretty good time. We're now going to look at exponential and logarithmic functions. So let's understand what the heck that even means. If we were to, say, look at a few functions, say y is equal to 2, y is equal to 2x, y is equal to x squared, and we look at, some xy tables here. Notice in this situation, it doesn't matter what x is, 0, 1, 2, 3, your y value is 2 all the time. And that's why you get this graph of a horizontal line that passes through 2. In this situation, 0, 1, 2, and 3, multiply 0 by 2, you get 0, you get 2, you get 4, you get 6. You see, each time it's going up by 2 units. That provides us with that slope of 2, which is why you get that graph. So this is a linear function. Y is equal to x squared, plug in 0, 1, 2, 3. 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. So you can see it's not going up by a consistent amount every time. You're squaring the x value, and that's why you start to get that curve shape that's happening here. It's a parabola. But watch what happens if we change it. So you can see the similarity here. They all involve a 2. Look at y is equal to 2 raised to the x power. So understand what happens in this situation. So, 0, 1, 2, 3, and I'll even go to 4 and 5 so we can see what's going on. If we go ahead and, plug in 0, anything to the 0 power is 1. Then 2 to the 1 power is 2. 2 to the 2 power is 4. 2 to the 3 power, that's 2 times 2 times 2 is 8. And then you have 2 times 2 times 2 times 2. It's going to be 16. So you can see each piece is being multiplied by 2. Next time you got 32, so on and so forth. And so you can see that the values start to get very large very quickly. And what happens is it starts at 1 and it goes up very quickly. Behind that, it goes like that. Let's investigate why in this situation. If you start to make some XY tables, in fact, I'm going to use my calculator for this just to kind of make my point, but it's be a good time to show you something as well for your calculators. You turn it on. Okay, I'm going to press second window. That brings me to my table setup. And if you switch this, so instead of the independent variable is automatic, switch the independent variable to ask. And now as I go to second graph, that brings you to a table. Now you can type in values you want and it'll produce a value for y. I'll go into my y equals and I had a weird function in there, but we'll type in 2 raised to the x power. And as you go to my table, now as we type in values like 0, 1, 2, 3, 4, you can see what it produces. Notice what happens if we plug in negative values like -1. Well, that would be 2 to the -1, which is 1 over 2 or a half. So we get 1/2. If you type in -2, you get 2 over, or I'm sorry, 2 to the -2, which is 1 over 4. And then -3, you can see you get 1/8. And then you're 1/16 and 1/32. So notice how these values here, they're all positive, but they're really close to 0. So what that means is that this shape, it has what we call this horizontal asymptote here, okay? And so this graph, it tends, as x heads off towards negative infinity, it approaches this asymptote of 0, okay? And that gives it its general shape. So let's talk about the parent functions that we have then. If a is greater than 1, say you have y is equal to, say, like 3 to the x, the parent function has a asymptote, horizontal asymptote of y is equal to 0, passes through the point of 0, 1, and it looks like this. That is the general shape, okay? Now, suppose that the a value is less than 1, okay, but greater than 0. So suppose you have, say, y is equal to, we'll say 1 over 4 raised to the x power. Well, that's the same as 4 to the negative 1 to the x power, which is 4 to the negative x. So if the x is negative, that creates what we call a horizontal flip. Whoop. So you can see that the graph is going to go like that. So if you have a fraction like 1/4, it's going to do that. Whereas if you have a number like 3, it's going to go the other way. We come up with a great number. E is just a very magical number. It's somewhat similar to pi in that it's irrational. It never repeats itself. And like pi, it has something to do with nature. So this is like y is equal to 2.7 raised to the x power. So if you do see E, don't freak out. It's just a number. It's about 2.7. And if it's raised to the negative x power, that would be like y is equal to 1 over e raised to the x, which again is a value less than 1, so it's going to have that shape. So let's practice some of our graphs here. So that's the last page of your notes. If you go to the front, it says sketch a graph of the following functions, state the domain, range, and asymptotes. Y is equal to 4 to the x. So because the base is greater than 1, it's going to have this shape. The asymptote is y equals 0. The domain is all real numbers, and the range is going to be from 0 to infinity. We do not include 0. 1/4 is going to look very similar. It's just going to do this. So in that situation, the asymptote is still y is equal to 0. The domain is going to be all real numbers, and the range is going to be from 0 to infinity. The domain for all exponential functions is all real numbers. That's technically not true. Suppose you had y is equal to 2 raised to the tangent of x. I don't know if we would really call that an exponential, but there the domain would be a little bit different. We won't get into that too much. This one, the question is it going to look more like letter B or more like letter A? If you answer letter A, you are correct because the base value is greater than 1. So the asymptote is going to be y is equal to 0, and the domain is all real numbers, and the range is going to be from 0 to infinity. So pretty easy so far. Let's look at the next one. So this is where we're going to consider our transformations. As you can see, we have this negative there. And what that's going to do is it's going to take the original function, which looks like this, and I'll draw the new function in red. It's going to create a vertical flip. So it's going to go through the point 0, -1, instead of 0, +1. It's going to go like that. So we still have an asymptote. That negative did not switch the asymptote. It's still y is equal to 0. The domain is always all real numbers. The range this time is going to be from -infinity to 0. But the next one is going to shift everything down 4 units. And so this asymptote, instead of going through 0, this asymptote is going to be down at -4. Instead of going through the point 0, 1, it's going to shift down and go through 0, -3. So this is my graph. The asymptote is going to be y is equal to -4. The domain is all real numbers, as it always is. The range this time is going to be from -4 to infinity. Again, do not include the -4. All right, now we get to one that's a little bit more confusing. Look at the 2/3. That tells me that the shape that it wants to be is something like this, okay? So that's what it wants to be. But what I'm going to do here is I'm going to shift everything up 1 unit, and I'm going to shift everything to the right 2 units. So watch how this plays out. This coordinate of 0, 1 is going to shift up 1 unit and then to the right 2 units. So it's going to go through there. That's its new point. It's going to go through 2, 2 as opposed to 0, 1. Also, this horizontal asymptote is going to shift it up 1 unit to be that location. So right 2 and up 1. The asymptote in that situation is y is equal to 1. The domain is all real numbers. And the range in this situation is going to be from 1 to infinity. So you should be able to perform transformations of exponential functions. Now let's just find the exponential function that passes through the following points. So we need something of the form y is equal to some number a raised to the x power. So we want to figure out what is a. Now, a lot of people on the test will write a is 4. Well, that's not an exponential function. Y is equal to 4 to the x. That's what I want. I don't want that. So let's think about this first example. It goes through the coordinate 0, 1. Notice all of these go through the coordinate 0, 1. That's because anything raised to the 0 power is 1. Okay, so the important number is 225. So that's the important coordinate. That's our y value. This is our x value. So what it means is that 25 is our y value is equal to some number a squared. So what is that number a that you square? That would be 5. So that means the function is y is equal to 5 raised to the x power. That is our function. The next one, -1 and 2/3. So I have 2/3 is equal to some number raised to the -1 power. What number would you raise to the -1 power to get 2/3? Well, 3/2 would be that number. So y is equal to 3/2 raised to the x power. For the next one, 8 is equal to some number cubed. What is the number that you cube to get 8? That would be 2. So y is equal to 2 raised to the x power. And finally, y is equal to some number, 1 over 10,000 is equal to some number raised to the 4th power. Well, 10 to the 4th is 10,000, so 1/10 to the 4th would be 1 over 10,000. So a is equal to 1 over 10. So y is equal to 1/10 raised to the x power. I do want to just let you know again, you could write this as y is equal to 10 raised to the -x. Those are the same functions. Either way, that's a nice introduction into exponential functions. Then we go into logarithms. And this test last year went quite well. I have high hopes for you this year. See you soon.